And if I have 18 out of 38, that will reduce to 9 out of 19. So if you do it in a fraction, you should always reduce your fractions. You bet on the first dozen would be 12 out of 38, which would reduce to 6 out of 19.
It kept the.
Did it accept their answers?
Yeah.
Not,
Yeah, it wasn't reduced.
is getting an odd number the complement of getting an even number? Is getting an odd number the complement of getting a
No,
even
because of
number?
the zeros.
Because of the,
Zeros.
What is the name
Not
for zero?
the
It's
same.
not odd or even?
So the even numbers would be 90, 20, 20 out of 38. And then the odd numbers would be,
Plus the zero.
well, here's where I'd have an argument with them.
yeah,
Because 0 is technically an even number.
yeah, that's what I'm
Huh?
saying.
Oh.
0 is technically even. What makes an even number even?
No.
0,
This is from
2,
zero.
4, 6.
No. What makes an even number even?
It's two plus
It's
two.
not odd. That is.
No, that's what makes a number odd. But what makes a number even by definition?
What is it?
They can be divided by
2.
2.
Oh, I
Okay.
see.
Sure,
That'll be zero.
yeah. But that's evenly divided because you get 0 and I get 0. So we each get the same amount, right? So mathematically, 0 is a even number because it can be evenly divided between two people.
Oh,
I thought
yes.
zero was neither even nor odd. They lied to me not
I'd have to look up and see what the exact definition was, but I always learned that the definition of even was divisible by 2. And
Okay.
if it's not even, then it's odd. So see, 1 is not divisible by 2 because if I can't split it 1 between 2 of us. I have to rip it in half, right? I can't split 3 between 2 of us because you get 1, I get 1, and we have to rip the other one in half. So now you've hit me on a question that I have to go look.
But according to WebAssign, it's no, right?
Now, I have to think according to the rules of roulette.
Yeah, according to Web Science, no.
Yeah. Okay, thank you.
But according to the mathematicians, that's it.
Yeah.
Okay. An even number is an integer which is evenly divisible by 2. 0 fits that definition, so 0 is even.
0 is an even number.
When was this added? Was this before elementary?
So,
They lied to us.
in that case, 0 and double 0 should be considered even, so they should be winners. But in roulette, they don't count them as even.
Because they didn't know the rule yet.
That teacher didn't rule.
Now, there are certain definitions that we sort of, because most of us think, what's the definition of a prime number?
It can't be divided by.
It can only be divided, it has what?
One at itself.
2 divisors, 1 and itself. So what's the first prime number? No. The first prime number is 2, because it has 2 factors, 1 and 2. How many factors does 1 have? 1. Itself. So 1 is not technically prime. 1 is neither prime nor composite. It doesn't fit the category. So 1 does not fit the classic definition of being a prime number. Mathematically, we don't consider it a prime number.
We need to make that extra credit on the test. That
So
one
those
and
are
the
some-
0.
One is neither prime nor composite.
Yeah. Because it only has 1 factor. And a prime number has to have
2.
2.
Because 2, 3.
1 and itself. So 2, 1 and 2, 3, 1 and 3, 5, 1 and 5. 9 is not prime because it has 1, 9, and 3. Now, for years, I considered one a prime number.
Yeah, I thought so.
See, again, they flipped it.
Yes,
No, they didn't flip it, I just learned a more precise
They
definition.
changed it.
In elementary, they teach it as a prime number. They do.
Not a million.
Yes,
I was just thinking about our test and how hard it's gonna be. And I remember you said if that went well, you would make us a practice test.
Ooh,
If what went
Google.
I said I would try to get you a practice test made. I do have some practice tests.
right,
made.
if you're surgery.
Oh,
Yes, that's
so, see, it would be, huh? You're allowed to have a cheat
We
sheet.
can, right? We can.
What's the rules about a cheat sheet?
Index card, handwritten.
Bye-bye.
Index card, handwritten.
What? We can't, no.
I was wanting to copy all
Can
the
we
web
type it?
signs
Can
and.
you get more if you type it? You can change it to fill in
Is type handwritten?
But, no, I think.
But the rule is it has to be handwritten.
On a 5x7, right?
How big is the index card? How
Every
no,
spell is
that's not quite defined. I can find the biggest
5x7?
index card.
Okay, so mutually exclusive. In roulette, what would be some mutually exclusive outcomes?
Even or odd.
Even or odd. You can't be even and odd at the same time.
Red or black?
Red or black, you can't be. Can you be in the first dozen in red?
Yeah.
Yes, so those are not mutually exclusive. So see, mutually exclusive just means they can't both, the probability of them both happening is 0. Okay, and basically those sort of do the same thing. Your sample space, if you flip 3 coins, all 3 coins can be, and if you think about this, take a dime, a penny, and a nickel. You can flip them, all 3 of them can be heads. Or the dime and the penny can be heads, and the nickel can be tails. Or the penny and the nickel can be heads, and the dime can be tails. So see, that's what this is saying. All of them are heads. The first 2 are heads, and the last one is a tail. So we just sort of look at that. So that is our sample space. Now, mathematically, I don't want to always have to list and count things. So what are the 2 outcomes I can get on flipping the first coin? Heads or tails. So the number of outcomes I have is 2. I flip 2 coins, I have 2 and 2, which is 4. I have 3 coins, I've got 2 times 2 times 2, which is 8. And that's how many outcomes you have there.
So if you would have
1, 2, 3, 4, 5, 6, 7, 8. So if I flip 4 coins, how many outcomes would I have? 16. So I'm just going to keep multiplying by 2. If I had 5 coins, no,
18.
no. 2 times 2 is?
4,
Times 2 is?
8,
Times 2 is?
16.
Times 2 is 32. Okay. Let A be the event that there are at least 2 tails. So if I go up here and count it, let me see, there's 1, 2, 3, 4. Because what does it say? At least 2 tails. Is 3 at least 2? Yeah. So 3 tails actually is 2 tails. So you count, even though there's no heads, there are at least 2 tails.
Wait, how'd you calculate the 3 coins? You went 3 times.
The first coin I flip has two outcomes,
Right, and then the second one only has one.
has two outcomes.
Right.
Because they're independent events. The flip of the dime is independent of the flip of the penny. If I throw three different coins up, I can get 8 different outcomes.
So you don't do the last one, you don't do the third one. You don't go 3 times 2 and 2 times 1 and 1
Not in
times
this
1?
one.
No.
Cause see, if I do my first coin, I can get a head or a tail. When I do the second coin, I can get a head or a tail. When I do the third coin, and see, I can get a head or a tail. When I do my third coin, it can be a head or a tail. So see, I can get heads, 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 or heads, heads, tails. I do the third coin here, I can get a head and a tail. So I can do head, tails, heads, or heads, tails, tails.
Oh, my lord.
I can do the tail and the head, then I can get a head and a tail, a head and a tail. So see, there's my head, 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 tail. And then here I get head, tails, head, heads, tails, tails, right? So I got 2 choices, 4 choices, 8 choices. Then I can get heads, or tails, head, head, tails, head, tails, tail, tail, head, or tail, tail, tail. So I get 2 possible outcomes here, 2 possible outcomes there, and 2 possible outcomes on my third coin. So 2 times 2 times 2 is 8. And then when I look at this and say at least 2 tails, 1, 2, 3, 4. So my probability of at least 2 tails is 4 out of 8, or 1/2, 1 out of 2. What was the next question? They didn't ask the next question. What would be the probabilities that I would get if I flipped 1 coin? What would be the probability that I get a head and a tail?
1 coin.
If I flipped 1 coin, what's the probability that I'd get a head and a tail?
0.
0, because they are mutually exclusive outcomes. What is the probability that I get 2 heads and 2 tails?
On 1 coin.
On this one where I have 3 coins?
0.
0, because it would be mutually exclusive. Okay, 2 heads and 2 tails cannot happen, because if I get 2 heads, the most tails I can get is 1.
Let's see another coin.
Let's see, I only have 3 coins. So this is what you guys gotta start getting and thinking a little bit more what the question, getting into the question. So the probability of Y and Z are independent. So if Y and Z are independent, the probability of being Y and Z would be what?
You're showing it to us.
If it said the probability of Y and Z were mutually exclusive, then it would be that. But if it's just independent, the probability of Y or Z is the probability of Y plus the probability of Z minus the probability that it is Y and Z. And if they're independent, they can happen on different chances, okay? But if this read mutually exclusive, then it could be this or this. G and H are mutually exclusive. So what's the probability of being G and H?
Not zero.
Zero. Okay, so that's what that's saying. The if they're mutually exclusive, what it's saying is that the probability of being both H and G is 0. Okay. Which other ones do you want me to go over? 13? Approximately 281 million people over the age 5 live in the United States. This is old data because that's now, well, maybe I'd have to go back and look at this. We'd have to go back and look at the Census Bureau data.
We just talked about that in that one, like,
Yeah. Of these, 55 million speak a language other than English at home. Of those who speak another language at home, 62.3% speak Spanish. So E speaks English at home. E not means speaks another language at home. Means they don't speak English at home. They speak another language. S means they speak Spanish at home. I gotta play with this. I'm not, so. It says part A, select E not. So that means I have to get my calculator. Okay, I'm gonna slide this over to this screen real quick. I'm going to get me another screen. Where'd my magic pen go? So the probability that we speak English would be what? 281 0 0 0 0 0 0 because that's all my people, right? And of these, 55 million speak a language other than English. So that means I would have 281 million minus the 55 million. So the probability of not English is my 55 million over my 281 million. Now, if I'm lazy when I'm punching this into a calculator, I can always ignore an equal number of zeros. So I could just ignore all the zeros. So for the first one, this one, I get 55 divided by 281. Handy dandy all-purpose calculators. I can't do that in my head. So 55 divided by 281 gives me 0.1957. They told me to go 4 decimal places, right? So this, now I don't want to do all that arithmetic. So I know that if I just take, this is going to be 0.80 4, 2. Because if they speak English, if they don't speak English, it's 0.1957. The opposite, those who do would just, these two have to add up to 1. So I just subtracted 1. I get the same thing if I take 281 minus 55 and divide by 281, I get the same answer. So since I'd already did the division down here, I just subtracted from 1 instead of doing all the arithmetic on the other. Probability of E. Again, those two have to add up to 1. Or else I could have done all the arithmetic, 281. And how many of you punched in all the zeros to do the divisions? See, my calculator's not big enough to punch in that big of a number. I can't hold that many zeros. So I have to be able to, because my calculator won't do that many digits. I can't type in 2810000. It doesn't go 9 digits. So I have to be able to wipe out the zeros and do it on this little cheap calculator that I'm using. Probability of S and not E. Okay, so S is speak Spanish at home. I have to think about this one for a second. The probability of Spanish and E not.
So you gotta find out how many people are, so like the 3,426,000, oh, 34,265,000 people speak Spanish. So we have to minus them?
Okay. Of those who speak another language at home, 62.3% speak Spanish.
Just multiplying. Because it's an and.
Yeah.
You have to turn that thing into a decimal first, right?
Wait, those
Yeah.
who don't speak English, okay, yeah, 55 million. Speak Spanish, 55 million,
Can you do the last one of that one though?
yeah.
Which one?
Oh.
Which window?
It's the given one.
That's the
So-
given, not E.
This one?
Yeah.
So it's the probability of Spanish given not English, which would be the probability of Spanish and English not divided by the probability of English not.
Got it.
Okay, so let me see.
Done the first though.
803, so the first, what I need to do now is
Green.
close this window.
And we
Can't
open our
do a lot
homework.
there.
Yeah.
Go to here,
Thought a lot about probabilities.
That
go
helps
to
a
the
lot.
top, go to assignments, go to score view. As you pull this off to the other screen, temporarily. Okay. 2,
I didn't
so
submit.
that's all.
It just submits for you, but
Not really.
Some like fun factors, you know, they get so
I think everything should just stay
always has a 57%
for sure. Cause I didn't get to finish the last
That's
one.
why my uncle and he does Las Vegas.
Like,
I always had those, like, the half houses that are. Well, I have this one friend who, I don't know how he does it. He always leaves some money.
Yeah.
Winnings.
Wow. Yeah, it was.
Okay, just because it was a little bit easier for me to do this, I will go ahead and try to redo this assignment between now and Thursday, even though it says that the due date is now the 25th, and that's just because it was easier. Well, it wasn't, it wouldn't have made any difference, I just actually hit a 5 instead of a 3 because I couldn't think of what Thursday's date was off the top of my head. So I just picked a number that I knew was higher.
Actually, but it's like, I can go home right now. I'm like,
We're talking about probability assignment number, probability assignment 2, right?
Got 3 delicious. I can't believe that.
You mean
Okay, let me take attendance real quick. Yeah.
Oh, I'm leaving and
Okay, Bronson is back there. Imani, not here tonight. Monique, where's Monique?
Right here.
Okay. So you've been here more days than I thought. 'Cause I didn't have
Oh
your
my
face. Leola,
I've been here every class.
Shar, here's Shar. Crystal,
The first class didn't count.
Crystal, Chelsea. No Chelsea, Megan, Jonathan, Joby, Danielle is right there. Okay. Leslie. See, I don't have everybody's